Yo, what's up, guys? I want to talk another excursion. It's a thought experiment, something we can't do, but we can think about. I want to know what happens if I can fold a piece of paper 50 times, if it was possible. How thick would that paper be? So this is what I mean. If I take this right here and I fold it, right? Right now it's one sheet thick, but if I fold it, now it's 2 sheets thick, and if I fold it again, it'll be 1, 2, 3, 4 sheets thick. And if I fold it again, it'll be 8 sheets thick. Now, this is another exponential excursion. Now, what we're going to do is think about what would happen. But instead of folding and actually doing it, I guess what I'd like you to imagine is actually a stack of paper and how tall that stack of paper would be if I just doubled how many pages or slices of paper were in it over and over 50 times. So I want you to think in your mind right now, how tall would this paper be if I stacked it up and I doubled it 50 times? Would it be as tall up to my knees, to my waist, to my head, to the ceiling? As high as a white pine tree? Would it go to the moon? I don't know. How high? So I want you to think about that. Say something. How high do you think it would go right now? I want you to think about it. And I want to talk about a few distances that are really important. Okay, here they are. A white pine is 80 feet tall, about. That's a big pine tree. The Empire State Building is 1,250 feet tall. A mile is 5,280 feet. So if you run a mile, that's how many feet long it is. If you go from Boston to Los Angeles, it's about 3,000 miles if you drive there. The distance around the Earth is 24,000 miles. Which is kind of interesting because it spins every 24 hours. It goes all the way around. So even when we're standing on the Earth, we're moving at 1,000 miles an hour. Well, down by the equator. If you're on the equator, you are. The further you get close to a pole, you're not moving at all. If you're standing on the North Pole, you're just going like this. Okay, anyway. And the distance to the moon is 240,000 miles away. That's far. Okay, that's 10 laps around Earth is how you get to the moon. And the sun is 90 million miles away, which is about 375 moon distances. So you go to the moon, that distance, 300, almost 400 times, gets you to the sun. Let's start doubling this paper. Here we go. So I start off with a slice of paper, and the first doubling, it becomes 2 slices thick. And the next doubling, it becomes 4 slices thick, and then 8 slices thick, and then 16, and 32, and 64, 128, 256, 512. Now I'm going to stop there for a second. Because a ream of paper has 500 sheets in it. And a ream of paper is 2 inches thick. So instead of talking about sheets of paper, I'm going to change this 512 to 2 inches. 2 inches. And let's remember, we're going to double this pile again. So that 2 inches becomes 4 inches. And then 4 and 4 is 8. And then 16. And then 32. And then 64. And then 128 inches. Well, 128 inches, we can think about how many feet is that? Well, it's a little bit more than 10 feet, right? Because there's 12 inches in each foot. So 10 feet is 120 inches. So instead of 128 inches, we'll change it to 10 feet. And let's keep doubling. We're already taller than me. Oh my God. 10 feet becomes 20 feet. 40. 80. 160 feet. 80. Look at, I'm already at the Great Pine. 160. 16 and 6. 320. 640. 1, 2, 80. 2, 5. 60, 1280, 256, 5120. Oh, whoops, right here it's 24. 5120 feet. Well, look at this. We were at the Empire State Building now here, and we doubled it, and now we're at 5120 feet, which is about a mile. Oh my goodness. 1 mile. Can you believe we're at 1 mile and we aren't even halfway doubling? Where are we going to go? Oh my God, exponential growth is crazy. I double that. I'm at 2 miles. Now I'm at 4. Now I'm at 8. Now I'm at 16. Now I'm at 32. Now I'm at 64. miles high of paper. And I'm not even done yet. 64 miles. And I go to 128 miles, and then 256, and then 512. And what is that? 1024. And that's about 1,000 miles. Oh my gosh. 1,000 miles. I'm just going to write this as 1K miles. Now we're talking about thousands of miles. Oh, double that. I'm at 2K. Then I'm at 4K. Now I can lay that stack of paper down from Boston, and if it falls down, it'll go boom across the United States and past LA. 4K, 8,000 miles. 8 and 8, 16, 32,000 miles. It's already would go all the way around the earth if it fell down. But now it's going straight up. We're going to see if we can reach the moon. Woo! Exponential functions are fun. They put the fun in function. 64,000 miles, 128,000 miles. Oh my goodness. So wait a minute, 60. We already, did we get to, oh no, we haven't got there. 128, 256,000 miles. That's past the moon. We're at a moon distance. We have a stack of paper. We've only doubled it 42 times, and we're already at the moon. 1 moon distance. Well, we're still going. Now we're at 2 moon distances, and 4 moon, and 8 moon distances, 16. And 32 times the distance to the moon, and 64 and 128 and 256 moon distances. Oh my God. How tall is that thing? It's 256 times further than the moon. It goes past the moon, and other than 255 of those. The sun is 375 moon distances. Which means that slice of paper, if you double it 50 times, you get past the moon, you get 2/3 of the distance to the sun. Okay? This is how hard it is to understand exponential growth. Because what looks like something that's not that big is. Hopefully that was a fun thought experiment. I like to do that in my class. Remember, exponential growth is hard to understand. So if you thought it was going to be 10 feet tall, that's okay. But it's not. So understand that maybe some other things you might not understand well also, and that's fine too. But it doesn't mean you can't learn about it. So hopefully you guys are all out there being safe, be a good neighbor, and have a great day.